Hello viewers, in today's class we are going to discuss one important problem from continuity of functions, right? So here we have to solve this problem in which we have to find the value of k, where k is some real number if the function f of x, which is defined like this, that is for x less than or equal to 1, it is the greatest integer of 1 minus x plus k square, and for x greater than 1 it is sine cube pi by 2x minus k square, and this function is given to be continuous at x is equal to 1, right? So if this function is continuous at x is equal to 1, we have to evaluate the value of k, right? So let us start. So let us first take the definition of continuity of functions. Suppose we have a function, say y is equal to f of x, which is defined in some domain D, right? Now this function f of x is said to be continuous at some point, say a in the domain, if the left hand limit is equal to the right hand limit, and both these limits are equal to the value of the function at the point x is equal to a, right? So the left hand limit and the right hand limit should exist finitely. That is, the left hand limit and the right hand limit should have finite values, right? And moreover, both the limits should be equal to each other, and then these two limits should be equal to the value of the function at the given point, that is x is equal to a, right? So here we are given the point 1, so a is equal to 1, right? So what we will do in this problem, we'll first find out the left hand limit, then we will find out the right hand limit, and then the value of the function, that is f of 1, and then we'll form an equation in k, thereby we can get the value of k. So let us start. So let us first find out the left hand limit, right? So the notation for left hand limit is the limit, then we'll write x tends to 1, we'll put a negative sign over 1, and here we have f of x, right? So here we have that is x is equal to 1 or a is equal to 1, and for finding out the left hand limit, we'll take a point which is in the left neighborhood of x is equal to 1, and this point is 1 minus h, right? And when we find out the right hand limit, we'll take a point in the right neighborhood of x is equal to 1, and this point we call 1 plus h, right? So that this interval is equal to h, right? Okay, so now limit x tends to 1 minus f of x, so we'll put x is equal to 1 minus h. So we'll convert this limit in terms of h, where h is infinitesimally very small and h is greater than 0 but less than 1, right? So when we take x is equal to 1 minus h, and when x tends to 1, then obviously h tends to 0, right? So now the left hand limit is given by limit h tends to 0, and we have f of 1 minus h. So now f of 1 minus h may be taken from this form of the function, that is for x less than 1 or equal to 1, f of x is greatest integer of 1 minus x plus k square, right? So now we can write limit h tends to 0, f of 1 minus h may be obtained by taking x is equal to 1 minus h. So we have greatest integer of 1 minus h, and then we have plus k square. Now simplifying it, limit h tends to 0, we have 1 minus 1 plus h, and here we have k square, right? So this is limit h tends to 0, 1 minus 1 is 0, so we are left with greatest integer of h plus k square. Now see, here we have greatest integer of h, and we know that h this h is greater than 0, but it is less than 1, right? So h is slightly greater than 0, so the greatest integer of h should be equal to 0. So now we have here 0, because we can also write it like this: limit h tends to 0, greatest integer of h is 0, and here we have k square. So now we have simply k square. So the left hand limit of this function at x is equal to 1 is equal to k square. So now let us find out the right hand limit. So the notation for right hand limit is limit x tends to 1, and will take a positive sign over 1, and here we have f of x. So now when we calculate the right hand limit, we are in the neighborhood of x is equal to 1, that is 1 plus h, which is towards the right of x is equal to 1. So we'll take x is equal to 1 plus h, and when x tends to 1, then obviously h tends to 0, right? So now the right hand limit is the limit h tends to 0, and we have f of 1 plus h, because x is 1 plus h. Now for x greater than 1, because 1 plus h is greater than 1. Similarly, 1 minus h is less than 1, right? So when we have f of 1 plus h, we have the function f of x is equal to sine cube pi x over 2 minus k square. So f of 1 plus h may be calculated by replacing x by 1 plus h. So we have limit h tends to 0, then we have sine cube and pi by 2, and here we have 1 plus h and minus k square, right? So this is limit h tends to 0 sine cube, and we have pi by 2 plus pi h over 2. And now we'll use some trigonometry here, because we know that sine pi by 2 plus theta is equal to cosine theta, and here theta is pi h over 2. So we have limit h tends to 0, and we have cos cube pi h over 2 minus k square, right? So sine pi by 2 plus pi h over 2 is equal to cos pi h over 2, and here we have the power 3. So now we have to calculate this limit and see when h tends to 0, then this term, that is pi h over 2, it tends to 0, right? So cos cube pi h over 2, it tends to cos cube of 0, because pi h over 2 tends to 0. So cos cube 0 is now equal to 1 cube, because cos of 0 is 1, so we have 1 cube, that is equal to 1, right? So the value of this limit is equal to 1. So we have now a right hand limit is equal to 1 minus k square, right? So the left hand limit is equal to k square, and right hand limit is 1 minus k square. Now let us find out the value of the function at x is equal to 1. So for x equal to 1, the function is defined like this, that is greatest integer of 1 minus x plus k square. So we have f of 1 is equal to 1 minus 1, taking x is equal to 1, and here we have k square. So now this is 1 minus 1 is 0, so greatest integer of 0 plus k square, and greatest integer of 0 is 0 plus k square, that is equal to k square, right? So f of 1 is equal to k square. Now since the function is given to be continuous at x is equal to 1, so the left hand limit is equal to right hand limit. that is equal to f of a, right? So we have RHL equal to LHL, that is equal to f of 1. So we can now have 1 minus k square is equal to k square is equal to k square, right? So now we have an equation here. So we can now write 1 minus k square is equal to k square. So 1 is equal to k square plus k square. So 1 is equal to 2k square. So k square is equal to 1 over 2. So k can be written as plus minus 1 over square root of 2, right? So viewers, the value of k for which this function f of x is continuous at x is equal to 1 is given by plus minus 1 over square root of 2, right? So this is how by making use of the concept of left hand limit, right hand limit, and the value of a function at a given point, we can solve these kind of problems.